Have you ever wondered about the vastness of time? The universe has been around for an incredible 13.8 billion years. But what if we could shrink all those years into a single year? This is the idea behind the cosmic year. In this cosmic calendar, each month represents a little over 1 billion years. Each day unfolds as 38 million years. Even a single hour on this scale encompasses millions of years. It's a humbling perspective, one that underscores the brevity of our existence. Within this cosmic year, the entire history of humanity is but a fleeting moment. Imagine everything from the first civilizations to today crammed into the final seconds of December 31st. But before that final minute, the universe was a stage for countless other wonders. From the fiery birth of stars to the slow dance of galaxies, the cosmic year unveils a story of constant change. Over the next few minutes, we'll journey through this cosmic calendar together. Get ready to explore the grand narrative of the cosmos, all within a single extraordinary year. Our journey begins on January 1st at the stroke of midnight. This is the moment of the Big Bang. Imagine a point of unimaginable density, infinitely hot, erupting with force. Space and time come into existence in this very instant. The universe in its first moments is a chaotic sea of energy. Temperatures are beyond comprehension, and the fundamental forces of nature are still intertwined. But the universe is expanding and cooling, setting in motion a chain reaction that will shape the cosmos. This rapid expansion and cooling lay the groundwork for the universe to transition from chaos to structure. Within the first fraction of a second, a remarkable transformation begins. The universe has cooled enough for the most fundamental forces to separate. Gravity, the force that binds the cosmos, emerges. From the chaos of the Big Bang, order starts to arise. Tiny fluctuations in energy density begin to appear, like ripples on a pond. These fluctuations represent the seeds of all future structure in the universe. Within these regions of slightly higher density, gravity will begin to exert its pull. As the universe continues to cool, the first particles, quarks, electrons, and their antiparticles form. These particles are the building blocks of all matter. The universe, now a few seconds old, is a maelstrom of particle creation and annihilation. Quarks and antiquarks collide, annihilating each other in bursts of energy. But a slight asymmetry in their numbers tips the balance. As the universe cools further, the surviving quarks begin to bind together, forming protons and neutrons. By the time the universe is 1 minute old, it's cool enough for protons and neutrons to begin fusing. This process, known as Big Bang nucleosynthesis, creates the first light elements, hydrogen and helium. For hundreds of thousands of years after the Big Bang, the universe remains a relatively simple place. It's a vast expanse filled with a hot, dense fog of hydrogen and helium. Gravity begins to exert its influence on the subtle density fluctuations that emerged from the Big Bang. These regions of slightly higher density begin to attract more matter. As these regions collapse inward, they heat up, and the pressure at their cores increases dramatically. The universe, once a calm expanse of gas, is now punctuated by pockets of intense activity. Within these collapsing clouds of gas, something extraordinary begins to happen. The temperature and pressure at the center becomes so extreme that hydrogen atoms begin to fuse. This is nuclear fusion, the process that powers the stars. The first stars are born massive and brilliant, illuminating the universe for the first time. These stars, composed almost entirely of hydrogen and helium, are short-lived, but incredibly luminous. The cosmic dawn has arrived. These first stars are not destined to shine forever. Their immense size and furious energy output mean they burn through their nuclear fuel quickly. As these massive stars reach the end of their lives, they explode as supernovae. These explosions forge heavier elements: carbon, oxygen, nitrogen, iron. The material from these supernovae, enriched with these new elements, is hurled back into the cosmos. The cosmic cycle from star birth to supernova and back again has begun. It's now March 13th in our cosmic year. The universe is teeming with the activity of newborn stars. Gravity draws together vast clouds of gas and dust into swirling, colossal structures. These are the nascent galaxies. Our own galaxy, the Milky Way, begins its journey as one of these massive clouds of hydrogen and helium. Over millions of years, this cloud collapses under its own gravity, forming the spiral arms we recognize today. The Milky Way is not a static structure. It's a dynamic, ever-evolving entity shaped by gravity, starbirth, and galactic collisions. Over billions of years, the Milky Way grows, pulling in smaller galaxies. These mergers fuel further star formation, adding to the Milky Way's stellar population. Within the Milky Way's spiral arms, new stars are constantly being born. The Milky Way continues to evolve, its story intertwined with the countless stars and planets that call it home. It's difficult to comprehend the sheer scale of the Milky Way. Our Sun resides in a relatively quiet arm of this galactic spiral, about 26,000 light-years from the Milky Way's center. We are part of this grand cosmic structure, bound to it by gravity. The Milky Way is but one of billions of galaxies that populate the observable universe. Each galaxy represents a unique story of cosmic evolution. As we continue our journey through the cosmic year, we'll zoom in on our own corner of the Milky Way. The cosmic calendar has turned to September 1st. In a quiet corner of the Milky Way, a vast cloud of gas and dust begins to stir. Gravity draws this cloud inward, pulling its particles closer together. As the cloud contracts, it begins to spin. And at the heart of this swirling cloud, a star is being born. The immense pressure at the core ignites nuclear fusion. Our Sun bursts into existence, bathing its surroundings in light and heat. The Sun's birth is not a solitary event. Surrounding the newborn star, a swirling disk of leftover gas and dust continues to orbit. This disk, known as a protoplanetary disk, is the raw material from which planets will form. Dust grains clump together, forming larger aggregates, which grow into planetesimals. Closer to the Sun, rocky materials will form the inner planets: Mercury, Venus, Earth, and Mars. Farther out, ices will form the cores of the gas giants: Jupiter, Saturn, Uranus, and Neptune. In the vastness of the protoplanetary disk, a small rocky world is taking shape. It's our home, the Earth, still in its infancy, a hot molten ball of rock and metal. The early Earth is a hostile place, with volcanoes spewing molten lava and a thick atmosphere of volcanic gases. Water, brought to Earth by comets and asteroids, begins to accumulate. As the Earth cools, this water vapor condenses, forming the first oceans. The stage is set for the next chapter in Earth's story, the emergence of life. The cosmic calendar has now turned to October. Earth, still a young and volatile planet, is about to witness an event so profound that it will forever alter its destiny. Deep within the planet's newly formed oceans, life is about to begin. Within the Earth's primordial oceans, rich in organic molecules, the impossible became possible. The first self-replicating molecules emerged, possessing the remarkable ability to copy themselves. This ability to self-replicate is the defining characteristic of life. The first life forms, single-celled organisms known as prokaryotes, were simple yet remarkably successful. They thrived in the harsh conditions of the early Earth. For millions of years, these early life forms dominated the Earth's oceans. A new type of bacteria known as cyanobacteria evolved the ability to perform photosynthesis. These tiny organisms absorbed carbon dioxide and released oxygen. As the cyanobacteria flourished, the levels of oxygen in the atmosphere steadily increased. The rise of oxygen was pivotal in Earth's history. For the first life forms, oxygen was toxic, but from this extinction, a new world emerged. Some evolved to use oxygen, unlocking vast energy. This set the stage for the Cambrian explosion. The oxygen-rich atmosphere today sustains life. December 17th on the cosmic calendar marks a profound shift in the narrative of life. The simplicity of single-celled organisms, while remarkably successful for billions of years, gives way to a new era, the age of multicellular life. Imagine the possibilities unlocked when individual cells, each with their own specialized functions, come together to form a larger, more complex organism. This transition from single cells to multicellular life is a giant leap forward, a testament to the power of evolution to create novelty and complexity. The first multicellular organisms were relatively simple, perhaps resembling sponges or jellyfish, their bodies composed of just a few different cell types. But these early pioneers paved the way for an explosion of diversity. In the oceans of the late Precambrian era, life took on new forms, experimenting with different body plans, different ways of moving, different ways of sensing the world. The seas, once dominated by microscopic life, were now teeming with a kaleidoscope of multicellular creatures. For billions of years, life had flourished in the oceans, protected from the harsh ultraviolet radiation of the sun by the water's embrace. But the land, a vast and unexplored realm, beckoned. On December 24th in our cosmic year, life takes another momentous step. Plants, the pioneers of terrestrial life, begin to colonize the land, their roots anchoring them to the soil, their leaves reaching for the sunlight. These early plants faced a daunting challenge. They had to develop ways to extract nutrients from the soil, to conserve water in a dry environment, and to reproduce without the benefit of a watery embrace. But they adapted, evolving new structures and strategies that allowed them to thrive in this new and challenging environment. With the arrival of plants, the stage was set for animals to follow. Amphibians, their bodies still tied to water for reproduction, ventured onto land, their limbs evolving from the fins of their aquatic ancestors. As plants spread across the continents, transforming barren landscapes into lush forests, the Earth's atmosphere underwent another profound change. Photosynthesis, the process by which plants use sunlight to convert carbon dioxide into energy, released vast amounts of oxygen into the air. The Earth's atmosphere, once rich in carbon dioxide, became increasingly oxygenated, creating the conditions for the evolution of animals with more active metabolisms, animals that could move faster, grow larger, and eventually take to the skies. By the end of December in the cosmic year, the Earth had transformed into the planet we recognize today, a world of blue oceans, green continents, and a life-giving atmosphere. The stage was set for the dinosaurs, the rise of mammals, and eventually, the appearance of our own species, a species capable of looking back in time and marveling at the grand narrative of the cosmos, all within the span of a single extraordinary year. As our cosmic year enters its final days, a new chapter unfolds. On December 26th, the dinosaurs emerge, their reign lasting a mere 4 days. Giants roamed the Earth, their footprints etched into the fossil record. Colossal herbivores like Brachiosaurus grazed on towering ferns, while predators like Tyrannosaurus rex stalked their prey. Their reign ends abruptly on December 30th, marked by a cataclysmic asteroid impact. A massive asteroid slams into the Earth, triggering widespread devastation. Earthquakes, tsunamis, and wildfires rage across the globe. Dust and debris blot out the sun, plunging Earth into a dark winter. The reign of the dinosaurs, cut short by a cosmic catastrophe, paves the way for the rise of mammals, small, adaptable creatures that had lived in the shadows of the giants. Among these mammals, a lineage will eventually lead to us, Homo sapiens. It's not until the final minute of December 31st, a mere 66 million years ago on the cosmic year scale, that humans make their appearance. Our time on Earth, compared to the vast expanse of cosmic history, is but a fleeting moment, a blink of an eye. Yet in that short time, we have become a force to be reckoned with, our impact on the planet undeniable. The cosmic year offers a profound perspective on our place in the universe. It highlights the vastness of time and the incredible journey of life on Earth. The sheer improbability of our existence fills us with awe and wonder, but also with a sense of responsibility. As we stand at the cusp of the future, we face a choice: continue unsustainable growth or choose a different path. Recognize our interconnectedness and the preciousness of our planet. The future is not predetermined, it's a story yet to be written. We, the human race, hold the pen.